Section 2, scientific foundations. We're going to lay the foundation that we're going to build our BFR house upon. So it's important we understand these concepts. They are not in the guided notes, and they are also not on the post-test certification, but they are still important. Acute stress is beneficial. Chronic stress is detrimental. Acute stress, these short-term stresses, these short challenges lead to growth and resilience. Chronic stress, the never-ending, constantly putting ourselves under more and more stress, leads to burnout and the inability to sleep. Hormesis is that positive adaptation to a short-term stress. Exercise, sauna, cold tubs, BFR, learning to play an instrument, learning a new language, a challenging math problem set. These are all short-term stressors that create a positive adaptation to that stress. When it becomes chronic or the stress becomes too high, right? The amount of that stress, we end up in the harmful dose, and that's when things don't go as well. One of the central dogmas of biology is that structure dictates function. The structure of a protein dictates the way that protein functions. Once you change the structure, you change the function of that protein. It might not function as efficiently, as effectively any longer. This is important when we come back to the benefits of heat shock proteins and how they can alter protein function. A lot of our neurodegenerative disorders can occur due to misformed or misfolded, misshaped proteins. Type 1 and type 2 muscle fibers. Type 1 muscle fibers are aerobic muscle fibers. They require oxygen. Type 1 muscle fibers, they're recruited first. They're low intensity. They cost less to run, so to speak. Your body wants to use type 1 muscle fibers whenever it can. Type 1 muscle fibers are used when you're walking, you're doing household chores, your posture is type 1 to maintain these movements, this posture in low intensity environments. Type 2 muscle fibers are anaerobic. They don't need oxygen. So they cost more because you're using a different energy currency, so to speak. Type 2 muscle fibers are recruited later. The body only recruits type 2 muscle fibers when it absolutely must use them. And that's usually when the loads are high and the intensity is high. Because those high loads and those high intensities change the muscular environment, which then increases recruitment of type 2 muscle fibers. When are type 2 muscle fibers activated? A hypoxic environment, a low oxygen environment activates type 2 muscle fibers. Mechanical stress activates type 2 muscle fibers. Metabolic stress activates type 2 muscle fibers. And then even muscular damage, which creates more metabolites. What stimulates muscle hypertrophy? A couple of different things, but really there are four main ones. A hypoxic environment, mechanical stress or mechanical tension, metabolic stress, and then also muscular or damage to those structural units. How does the nervous system recruit more type 2 muscle fibers? As hypoxia increases, so hypoxia is a decrease in oxygen. That's a hypoxic environment. So when oxygen decreases, there's more metabolic stress and there's more mechanical stress. The body's going to increase its recruitment of type 2 muscle fibers. So when there's low oxygen, you can't use type 1 muscle fibers. And that high mechanical, that high metabolic stress shifts the body away from type 1 into utilizing type 2 muscle fibers. And that is known, as we'll touch on this later, but the Henneman size principle. And that's where early on, when force production is low, like walking, lifting light loads, the body's going to only activate type 1 muscle fibers. But then as the body needs to recruit more muscle fibers to produce more force and more power against a heavier load, you're going to see an increase in type 2 muscle fiber recruitment. And this brings us to our third section, blood flow restriction basics.